Okay, welcome back. So, based on the last week classes, mm, I received few very interesting review, and yeah, good. Few students still did not send me the theory part, but who sent? Yeah, it's kind of interesting. Your point of view. What I just want a little bit more mention here, it's again when we talk about simulation, and in the most of your reviews also, you focus, I think, too much on the practical things of simulation. Yeah, I tell you, simulation is nice in physics, in like science, to simulate the environment, to do some calculation. For medicine, I don't know, for production, to build in virtual space first and after test. Yeah, entertainment. But yeah, in case of our artistic practice, it's much more interesting because few of you mentioned that the interesting here is to create what we can experience in the real world, right? That's also point of virtual reality, for example. Again, if I will go to virtual reality and see what we have in general. Yeah, we have games because it's fun. We I don't know what now Google will tell about based virtual reality, not headsets, experience. Still headset too much. Because if we gonna watch what to do, okay, Google Cardboard is up. Within, uh, yeah, within is more like some videos, animation there. It's kind of interesting. Expedition, yeah, I saw a few of this up. You can go to Everest, but it's still you not really can experience. You cannot experience cold. You can't experience altitude. You cannot experience the tiredness you have there. You cannot experience the smell. So yeah, this is could be fun to relax, do something, but it's not really, I think, worth to experience in virtual reality, right? Or something quote, I don't know, walk on the Mars. Yeah, this is something more interesting because that's what we cannot experience at least now, right? And I don't know any like simulation of the non-existent universe. That what I think could be interesting for artists, and that what we're doing in our works. We taking point of something and we try to simulate it and give experience to people, to visitors, right? Because yeah, like Tony also mentioned, it's pretty much impossible to simulate the for us it's impossible to really simulate the real world because we don't have this computational power. And here it's also have theory about the like if simulation worth it, but if it's like to simulate our universe we need to computer bigger than our universe. Because yeah, it's when we simulate something from practical point of view, science, technology, or from artistic point of view, we focus on one point. Yeah, we cannot think about all unpredictable variables that can affect us. So that's how it's called in the science. It's like in vacuum. Yeah, we put some object, we take it out, and we put it in vacuum. Okay. For example, now when we simulate these rules, it's pretty much vacuum. We have like empty space that is, it does not have temperature, it does not have like any other influence. It's no like other people coming in or going out, and it's kind of a lot of things we not really simulate in our environment. We can do it. We today we will continue to make model more complex, more interesting, yeah. But we for now pretty much we can go to very high level of complexity, spend a lot of time and add everything, but here you just think for your project if it's matter or not matter, yeah, if it's important or not. The same even if you're gonna build simulation, the nuclear reactor, yeah, it's very important to simulate physics and maybe some like unpredictable events like earthquake, I don't know, storm, whatever, because you don't want it explode from anything, something like this happened. But at the same time, you cannot simulate like I don't know, some human factor, right? Theoretically, you can, I think, but it's just like very unpredictable what person can do if it's in bad mood or it's tired or forget. I mean, this is human. That's why it's called human factor, right? So, and to try to simulate this human factor, gonna be just too expensive and complex, and pretty much not actually you can tell, okay, now we do it. If you're interested in this of computation and yeah, you can check this one, computational reducibility. So basically it's kind of like interesting phenomenon where like some things you just really cannot lower down to computation, at least for now, because we does not understand it. The first point when we're doing simulation, you need to understand what you simulate, otherwise you cannot do it. So what we're talking about, okay, so in your theory, mostly pretty much all of you focus more like on practical things here, but I want you also remember from artistic point of view, and I would tell you that yeah, simulation is not just in computer. You do simulation every time in your brain. Okay, when you go to class, you think what's gonna happen on the class. When you go to dating, you start thinking. You can try to predict or plan how you want this dating to go, right? Before you start to do your work, you also try to visualize it in your head and think how it's gonna work, what it's gonna do. This is also simulation, but it's just simulation in your brain. Yeah, Ananke put like also right. That's what happened in our dreams when we're sleeping. Our brain just our brain always doing simulation of the world around us. What we see, what like we think about world, it's not really what is. It's what our brain simulated for us, right? Based on our experience, based on our sensors. Even if you, I don't know, if you're blind, you see the world different. Yeah, if you're colorblind, for example, you cannot see some few colors. The word still the same. You just perceive it's different. But it is easy example. Yeah, colorblind is just like straightforward. Yeah, some kind of like illness. But the same I can tell about, for example, if few of us before did not know about simulation, you saw on the world of from point of view with no simulation this world. Now when you know, you can see some object and you can see, okay, it can be simulated, it can be not. It's already different word for you now, different experience. So it's all about simulation at the end, especially when you try to create something new. Yeah, you first it's simulate in your brain, after you try to simulate it in virtual space, and maybe after you try to build it. Yeah, this is pretty much everything about theory. So we have simulation not just in computer, it's happen in our brain, it can happen in different ways. To do simulation, to build simulation, you need to understand first how it's work. If we cannot understand it, we have this computational reversibility, or we cannot simulate consciousness, yeah, or human brain for now, because we just cannot understand it yet. We don't know how it's work, what happened there. And yeah, this is pretty much for theory. About practical question, it was not much question, so I can do. Why we use this one here? The sick and there's no symptoms. So sickness we have 1, 2, 3. When sick is true, function no symptom. Yeah, because you know before the virus, before you have symptoms, yeah, that's why we have quarantine for like 14 days. So you can be sick for 2 weeks, but you will not have fever, you will not have cough, so you will not have symptoms. That's why when the person becomes sick, we just randomly set up for this person how long he will be sick without symptoms. So it's from 70 to 21 days he will be sick without symptoms, but he already can infect other people. That's why we do it here. Because no symptoms, after we just, if it's more than 0, so it still we doesn't show symptoms, we every frame with minus minus. So after it's equals 0, we start to show color. It start to have some symptoms, fever, cough, whatever, right? That's why we use 2 condition here. Switch. We did not learn switch. Yeah, but it's quite simple operator. I think you just basically can check documentation of the processing side. So I can set up int current equals 0, for example, size 100, and if current more than 3, current equals 0 again. Print ln current. So I can run this now, and you see every time I press button, now I change, yeah, it's go from 0 to 1. And that we can do it's like this, one solution. If current equals 0, background, let's say black, else if current equals 1, background, let's say 50, a bit brighter, 1, 2, 3, 150 to 55. So now you see that's what we did before, yeah. But when you have a lot of this kind of conditions, if else getting a little bit, no, I mean just like it's not easy to read and not have some problems. So for this we can use switch operator. I tell switch current, so switch, and I give the variable that I wanted to check, and after I can in case it's 0, if current equals 0, background 0, and I need to break it, otherwise it will go to the next one. So break it still okay. And now I just can do like this. Case 1, case 2, case 3. And we can have default here. Okay, default 0 also. So now I can, for example, delete 0. So if it's current 1, this is gonna happen between case and break. If it's current equals 2, this is gonna happen between case 2 and break. If it's 3, this. If none of this is gonna happen. So now when I start, you will see the same. Yeah, it's the same effect. So switch it's another condition, like if else, it's just more useful in case you have a lot of different conditions. So you don't need to write else if, else if, else if, else if. And it will be a bit faster also. This is no, if it's from 0, it will include 0 also. If here will be from 0 to 3.5, it will include 0 also. But 0, it means it's not sick. We already defined. So 0, it's just like our check to set up it. So if we set up random from 0 to 3.5, value could be 0 also. But if it's value from 1 to 3.5, it will be 1, 2, and 3. Why to use normalize? That's where we, because you remember, I talked already a few times this part. Photoshops. Too big. We have our object and we have another object, and we want to find direction between them and distance. So we calculate this vector, yeah, position this minus position this. This is gonna be this vector, but this vector, okay, they can be more far away or they can be closer. Yeah, here it could be another object. Here it could be another object. This object have different vectors, this and this and this and this, but they have the same direction. So here we need to find the direction to make it move, because it movement not based on the how far away them it will affect our force acceleration, but here I need just to find the direction. Direction is the vector with length 1. You remember we have class about vectors a few weeks ago. So to find the direction of this vector, direction of this P1, P2 and P3, P2 will be the same, but they will have the same length magnitude. This is a different length magnitude, but they have the same direction. So here we need direction. to make it move. And after we multiply this direction to speed to move it, okay? So this is pretty much all questions from last week. Yeah, so for now we will keep work on it. Okay, we have our simulation and our model. So what next things to do? Yeah, here is sickness. Now we need to calculate, okay, when the person gets sick, we need to see how okay, when the person gets sick, the first, it need have some time to become healthy again or to die, right? This is we need to calculate. So we need to have the recovery probability if it's light sickness, medium sickness, and high sickness. And what we also will to do, we need to create, I think, one more. It's gonna be not the recovery probability, it's like death probability. And this is I can set up, okay. If very light sickness, the death probability gonna be very low. Let's say 1%. Like even not one, like 0.5%. If it's middle case, let's say this probability gonna be 2%. And it's very sick case, the death probability gonna be, let's say, 10%. Again, this is not actual numbers. This is just assumption for our scenario. And now what I need to do, pretty much every period of time, I need to check if it will recover or if it will die, right? And for this, I think I will change. This is like 0.9 is like overall recovery probability, but this is like is at current time step the death probability. Let's say it's a little bit smaller. Let's to simplify our model, we can use recovery probability also at current time step. So if you light sick, like let's say 10% of time, you will recover. If you medium sick, you will recover after, let's say 5% time. If you hard sick, the variations you will recover, it will be, let's say 1%. And here I will create signet long int we can go to processing types. Okay, let's go reference data types, data. We have long, so I think we're gonna use long here because long, it could be very long number. Int have limitation, but when we talk about seconds here, it's a little and no, we don't need long here. We need int here. Int next check. I will call it, and by default it's 0. So and now here, where our signals, what I will do, if next check equals 0, I will check on recovery and this. If it's not 0, I do next check minus minus. And again, after I do this check, what I need to do, I need to set up the next check equals, oh, we can set up some random number also. Okay, let's for now set up, okay, every 60 frame I will check, every second I will check. And we have recovery probability and this probabilities. Okay, here what I can do now, if random at 0 to 1 less than recovery probability 0, what we need to do, we need to set up this sick and this no symptoms to 0. Sick false, it's recovery. This no symptoms to 0 again. Right? This is not belong to current one. If it's not recovery, I will have another condition. If random from 1 less than this probability, we need to create one more. We can make like bool alive boolean. So when we create new, we set up this alive equals true. And when we will draw and do update, we will create one redo. Okay, first, if it's dead, we don't need to update it, right? So where our updates function, I can check if this alive true, I do this. If it's not true, if alive update. If not, we do nothing with this. And here for draw, for example, what we can do for now, let's create also if I will do it here for now. If alive, if it's alive. I do this part. If it's not alive, I will just, I don't know, RG. I will make it blue if it's that. So, and now here, if it's random number gonna be less than this probability of the first one, it's gonna be def. So this alive equals false. And now we can copy it for each of them. We just need to change here to 1, and we need to change here to 2. Let's run it and see. Oh, okay, you see this one dead, another all recovery. But here we can make it simpler also. We don't need really to use this like switch, because it's 1, here is 0, if this 2 0 1, so we can just use this thickness here -1, this thickness here -1, and I don't need all of this condition in this case, right? I think I have one extra here. If random this, oh, maybe not. Let's try run. Okay, yeah, error, because when I delete, I think I have some extra. This one, if thickness. I think I just delete here one. Okay, it was here. So this one I need to put inside, and I need to delete this one. And for thickness, let's maybe we can also create something boolean recovery false, so we can see the one who recovery. This recovery false. And here I will write this recovery true. And when we will draw them, we also can do check. else I need to check here if this recovery I will fill green, else it's gonna be white. If it's just normal one, white. So here we checking if it's alive, we do color. If it's not alive, it's blue. It's blue. After we check if it's sick and it shows symptoms, red color based on symptoms, right? If it does not sick or does not have symptoms, we check if it's recovered, it's green. If it's normal, white. We can start. We get sick, 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 sick. Okay, this die. This is recovery. These two still sick. This is die. And this is die also. So 1 recovery, 3 dead. I think we can set up also here some time. Int check time, let's say not 30, let's say 20 frames. So 60 now, it's a little bit long, at least for now. And here let's use more clear that it belongs to current one. So now we have normal one, we have sick with different symptoms, we have normal white, sick red, dead blue, recovery green. So next one, what we need to do, we need to make people be infected. 6. So it's gonna be a few different ways. So if I have my this is one, the normal one, and this is one, the sick one. So what I'm gonna do, if it's sick, I will have some radius around this, where I will see if it's other element inside of this radius, I will infect it with some probability. Yeah. Because, okay, I think we're gonna do it in the check private space because we already do this calculation, right? Check private space, all other elements. If not current one. Calculate distance. And here I check if distance less than the private space, apply force. But I will add here one more. If this seek if current seek can infect others. And let's say that it can infect with the distance private space multiplied by 2. So you can infect people not just like around you, but a little bit more far away, right? And I will create float coefficient, and it will be 0 by default. After, what I'm gonna do, I will write I will create another float infection rate, and this will be something like this. So first one, if you sick but you does not have symptoms, you in 5% of time you will infect it. If you sick but you have very low symptoms, you will affect another one. Let's say here like 1%, here let's say 5%. If you have middle 6, you will affect 0.1, and if you hard sick, you will affect in 15% of cases. So here, if person I, no, if the 6, I need to use this is sickness, this sickness. So here we see this sickness 0, sickness 1, sickness 2, sickness 3. Coefficient based on sickness. All right. So here I can write basically less infection rate what's the name? Infection rate, right? This sickness. Let's make shorter. So this is how probability that it will infect other one. And in this case, I need to do person Y sick get sick. I will call this function, but this function does not exist now, so I need to create this function. Void get sick And basically how it gets sick, it's just, we need to set up this one, this, get sick, and this recovery we set up to false again. Okay, if, and so here we have coefficient, and again if random from 1 less than coefficient, it will get sick. Let's try. I think it's a little bit too big number, but let's see. Oh, one dead here. Here one more things, because when it gets sick and it gets infected by other, the no symptoms restart again. So here what I need to do, if I need to add one more condition, if this sick false. So if the person not sick, he will get sick. Otherwise he will not get, because otherwise I will just like put to 0 again. Okay, now you see how it's our infections start to spread. And how our population dying. Yeah, it's a little bit big number, I think so. I think first we need to adjust here, maybe 0.2%, 0.1%, 0.5, and 0.1. It's still a little bit too big. What we also can do, for example, we can check when we calculate this coefficient, we can also check if person Y recover So if this person was sick before, but so it have some immunity to this. So in this case, I will write coefficient gonna be coefficient divided by 2. So the person that was sick before, this recovery, it have like 50 times less probability to get sick again. Let's help. Okay, I think also maybe the distance here a little bit. Let's just use the private space also. Okay, now it's a little bit more interesting, but you still see that it's like virus spread a lot, right? Also, we can use the same map function for the distance. Coefficient equals coefficient multiply by map function. And map function gonna be the same. Distance from 0 to this private space, less 1.5, and let's here still like 1.5, make it a little bit bigger. And if it's very close, the coefficient to get sick gonna be 1.1 multiply. If it's like far away, it's gonna be 0.1. So then more far away you from the infected one, the less ability you will get sick. Okay, you see now it's still, but it's a little bit more complex now. If recovered, have immunity. Maybe here even like not by 2, by 4 times less. Next one, what we can do, let's check our mask theory. Not theory, it's really happened, yeah. So now we will create one more value here, boolean mask false. And let's say at the beginning this. At the beginning I would say that if float mask coefficient mask vir coefficient less equal 5, 50% of case they will vary it. If random from 1 less than mask vir coefficient, this mask equals true, else this mask equals false. And let's create one more condition here. I want to check also if we're not gonna talk about that person now, yeah, that person not gonna infect alive. So we will check just if they alive. Actually, this I can do here also. Person I alive. I do all this calculation. It will be speed up program. And you see how now it's kind of like more interesting behavior, but it's still a lot of people sick. Mask false, random default mask. And let's also do one more things. I will create here if this mask. I will create one more ellipse, just maybe a little bit out with size of 3, and it will be white. So now we will see how many person wear mask. Yeah, okay, maybe it's too small, Let's make 5. 5. Yeah, now we see how many people wear masks. And let's make it blue, I think. Let's say 100, 100, 255. So light blue. So now we see who wearing mask. And for that person, let's make it black. So not mess up. Okay, and so now in our coefficient, when people get sick, we can also calculate if this mask true, coefficient gonna be multiplied by, let's say, 0.3. So it's if sick person wear mask, it's gonna infect in 0.3, like in 30% of case. And also what I gonna do, if person I wearing mask, coefficient gonna be even smaller. So now we see that we'll see that by default people wearing mask. Now we have much more sick people, you see. So it's still kind of a lot, but it's already better. I can create here a float mask infection coefficient, let's say 0.2. And I will put it here. If wearing mask, less probability to get sick. Closer, easy to get sick. And here, if have immune system already. You see, even in 50% of mask, it's helping us. What if we'll make 70% of people wearing mask? How it's gonna looks now? You see, we still have infection coming on, but it looks like should looks like slower. Okay, if we have 10% of people wearing mask, yeah, you see it's just becoming red very fast. And after it becoming black very fast. If 90% of people wearing mask, we have just very few cases, and it looks like, yeah, some people get sick, but we have not much dead people. We still have some people get infected, but it's much slower. Now we have more and more green. And I think after some times when we will run it, most people will have immunity and not gonna get sick. Yeah, so here you see if 90% of people wearing mask, green win, right? We can make it a little bit more interesting. We can create some personal immune system. So when we create every person, I can write float immune equals 0. So every time I will create a person, I will set up immune to some random number. And let's say it's gonna be, okay, 0.1. It's very weak immune system. For example, very old people or sick people, right? And the second one, 0.9, it's very strong person with very good immune system. So now I can also do this, use this for my calculation coefficient. I can run coefficient. It's gonna be coefficient multiplied by, I will use another map function, and this map function gonna map my immune system. If my immune system 0, I would say I will have probability 1.2%, 120% to get sick. No, wait, it's from 0. Okay, 0, 1 to 1. So if it's 0, 1, I will get sick. And if my immune system 1, I will get sick in 10% of cases. And let's also visualize our immune system here. So when we will draw this one, I will draw 255, green, 255, let's say 100, 100, and here it's gonna be this immune multiplied by 255. So now we will see the darker people have not so strong immune system. The brighter people have stronger immune system. And if recover, it's become green. Let's say like this. Okay, the dark people have weak immune system. No, let's say something like this, 100, and here 100 plus 155. Okay, more green, the better immune system. The red still sick. The black dead. And the strong green is recovered. Okay, see, in this case we pretty much eliminate the virus, it's still spread. Okay, next thing, so what we do is like social distancing, for example, right? And for this we will create just one more coefficient, float social distance, and let's say we set up to 2 for now. And this, where we need to use where we check if the person too close to each other. So if our social distance coefficient bigger, people will try to stay more far away from each other. So our social distance 2 now, they will try to stay more far away now, but virus spread the same, so this should eliminate virus. But you see, because we have too much of them, it's in some cases it works a little bit opposite, right? Because we does not have so big space here. It's creates quite of interesting, let's say 0.5 social distancing. And where we have our personal private space out here, private space from 2 to 10 size, let's say a little bit smaller, from 2 to 6, and social distance still 2. Let's try. Person position from current, I think here it should be negative to make them try to be, yeah, more far away. So now you see they try to stay like more far, like really far away from each other. And for the private space, I think we will start from 2 to 4, and I think we need to lower our population down because our screen not so big. So now you see they really spread. Let's make screen size bigger. And when they really spread, it's still too big. Okay, let's make size smaller first. Okay, this is a little bit more how it should behave. I just have too much of them. Or, for example, I can set up the social distance 0.5. It's just normal scenario. They can be close to each other. So have some problem where they get like too close to each other. Yeah, now it's right. So they try to keep away. They move in different direction. Yeah, and they have some social distancing. And I does not see much sick person now. Okay, spreading. Okay, let's say 70% people wear mask. Let's see how we have our immune system. Okay, no one get die. I think for immune system I put 2 big values now. So if you have a good immune system, I think it's gonna be 0.3 or like say like 0.5. Still like very healthy people still get sick with this virus. Again, we'll eliminate them. 6 start, or the 6 start. 1%, let's say 5% of people get sick. So this pretty much, you can make it more interesting. For example, by you can adjust different social distance. So some people follow the rules, some people don't follow the rules. We can also use our immune system about how recovery and the death process going. So you can work on it, make it more and more complex system, and see what result gonna be. And let me clean this part for now. And like this is also kind of interesting to see how this evolve. So pretty much you can do artwork visualization by simulating virus model. Yeah, this is pretty much all for today. You can play more with it. And next week, next class, you will have, it's gonna be your second test. You will need to do the simulation, your own simulation. So that's why last class you have small homework to prepare to figure out what you want to simulate. So get ready for next week. It should not be complex, but it could be interesting. So this is not complex model, but yeah, it could be simpler. And again, we can make it more and more complex by adding different parameters. We can add temperature, weather that will affect how virus spread. We can also affect if some, like after people leave the trace, yeah. If like I'm not near the person but I pass where is the like sick person passed before, you can get sick, and so on. Yeah, that's all. See you next class.